Good Monday morning. On behalf of KPCC and Southern California Public Radio, we welcome Planetary Radio Live to the Crawford Family Forum. In today's program, it's rocket science in action again. NASA is launching MAVEN, the Mars Atmosphere and Volatile Evolution, and we're here to see it. And now your host, the producer of Planetary Radio for the Planetary Society, Matt Kaplan, to the Crawford Family Forum.
Welcome, everyone, to the Crawford Family Forum at Southern California Public Radio. It is 9:35 in the morning. We got some feedback here that we'll get rid of in a moment. So you know that this is a live program. And it's, as I just told the audience that's here with us today, it's going to be a little rough around the edges because it's live. We are here to celebrate the launch of the next mission to Mars. Now, the last launch, as you're going to hear a little bit later, not very far from now, only just happened a few days ago. We'll hear about that one as well. I do want to start, even before I introduce my guests, with a unique photo, a unique image of Mars that I think you'll enjoy. Whoop, little strange aspect ratio there, but can you tell? Can you see Mars? I bet you can't, because you may not know where to look. Let me show you where to look. Way out there is a tiny, tiny little dot, in this case a red dot. We're the pale blue dot in the lower right. This was actually taken not long ago, last summer, by the Cassini spacecraft, which of course is orbiting Saturn right now. This is not the first time Cassini has done this. It's not the first time we've had a selfie from space looking back toward Earth. But it is a particularly spectacular image, I think you would agree. And sure enough, in this one are some other sisters of that big ringed planet. You've got Venus, you've got Mars up there on the upper left, a tiny little dot. I'm afraid Phobos and Deimos are probably too small to show up there at all. And the Earth-Moon system. By the way, because the Cassini mission, you should know, is in some jeopardy. It is supposed to run for several more years to finish the amazing science that it is doing by itself out there in the outer solar system, unless you count New Horizons. It's in some jeopardy, and that's something that we care a lot about at the Planetary Society, that we're reporting on and advocating in Washington about. And you can learn more about that at planetary.org. And also on episodes of this show. In fact, we hope to do a show fairly soon, maybe early next year, about the threat to the Cassini mission at Saturn. But we're here to talk about MAVEN and Mars. And with that in mind, I want to introduce a couple of my colleagues who are going to stay up here on stage with me for the duration here, and we hope it's going to climax with a launch. Emily Lakdawala is a planetary geologist. She's also senior editor and planetary evangelist for the Planetary Society and a contributing editor to Sky and Telescope magazine. She is a weekly regular on Planetary Radio, providing her unique view. And you can see that view, you can read and see that view every day at planetary.org in the blog, which is one of her major responsibilities for us as our senior editor. Please help me welcome Emily Lakdawala.
Thank you very much, Matt.
Dr. Bruce Betts is the Planetary Society's Director of Projects. He is an astronomer, a planetary scientist. He teaches an online Intro to Astronomy course that anybody can do. There's still another one coming up, isn't there? Yeah, we'll get him to tell us when. He does that for CSU Dominguez Hills, and we'll hear about how to tune into that and learn a lot more about the solar system and beyond. He's also my cohort for the What's Up segment that we will be finishing today's show with. It comes up at the end of every episode, including this one. Please welcome Dr. Bruce Betts. And as you may have heard, we've got some other guests that we're going to be joining in Florida, people who are at the Kennedy Space Center to watch the launch, which is not from the Kennedy Space Center. It's from Cape Canaveral, or so I am told. But they have the people gathering at the Kennedy Space Center. And indeed, we are going to try and connect with the CEO of the Planetary Society, Bill Nye the Science Guy. We've got some very distinguished people I see out here in the audience as well that we may want to call out later today when we do our Q&A segment. Back in late August, I visited the University of Colorado, Boulder. They have there a laboratory called the Laboratory for Atmosphere and Space Physics, or LASP. And that's where Principal Investigator Bruce Chakosky has led the MAVEN mission. You can hear my conversation with Bruce. That was part of the September 16 Planetary Radio, which you can catch in our archives at planetary.org. I have to tell you, I was thrilled and surprised and a little ashamed when I really learned about this mission from the people who have been working for so many years to make it come together. I had missed how very, very important this mission is for revealing to us the past history of Mars, including whether there may have been a past history of Mars that included life. And that is very much something that we'll talk about later. We also, though, have a little brief overview for you of this mission from somebody who knows a thing or two about navigating the cosmos. We can run that video now.
NASA is returning to Mars. Why? Well, to help solve one of the big Martian mysteries. Where did all of that Mars water go? NASA's Mars Atmosphere and Volatile Evolution Mission, or MAVEN, will explore Mars's climate history and gather clues about the questions scientists have been asking for decades. MAVEN will look at specific processes on Mars that led to the loss of much of its atmosphere. And MAVEN data could tell scientists a lot about the history of climate change on the Red Planet. Billions of years ago, Mars probably looked more like the Earth. Large, flowing oceans or lakes, an atmosphere as thick as our planet's, and perhaps life. Yet recently, NASA confirmed evidence of a past environment on Mars well suited to support microbial life. But something has happened. Most of the atmosphere is gone. The planet is cold and dry at the surface and decidedly inhospitable to life. Now, the most likely culprit is the sun. And MAVEN data will tell us a lot about how the sun interacts with planets and their atmospheres. MAVEN will take a significant step toward solving the planetary puzzle about Mars' past and present environments, and by comparison, may reveal some clues about Earth as well. When MAVEN arrives at Mars in September 2014, it will join ongoing NASA missions Odyssey, Opportunity, MRO, and Curiosity that continue to improve our understanding of Mars and the evolution of our solar system. NASA is committed to a program of Mars exploration with the goal of sending humans in the 2030s. The data from these missions and those to come later this decade will inform future human exploration as well as provide textbook-changing science. The next step in our exploration of the Red Planet is MAVEN and the mystery of the missing atmosphere. And maybe someday, NASA robotic Martian detectives partnered with human scientists will answer the age-old question, was there ever life on Mars?
I still have trouble recognizing him without the visor, don't you? Emily, what excites you most about this mission?
Well, I think it's trying to answer this question of how we got the Mars that we have today from the Mars that presumably existed in the past. Evidence from a couple of rovers is now strongly suggesting, and also several orbiters, strongly suggesting that Mars did have an environment that had plenty of water to make a nice neutral pH environment to create these clay minerals. And so something happened to that atmosphere. We want to know how Mars lost its atmosphere, whether it went out into space or down into the rocks, and when that happened, and the time sequence of events. And so with MAVEN in the sky and Curiosity on the ground, we're really going to get access to these kinds of scientific questions.
I've got a slide that they showed a version of it in that little LeVar Burton video. And again, it's a little out of aspect ratio here, but you can see a progression there. And the progression is really backwards, I think, because it seems to me that that watery Mars ought to be at the other end. And it
depends on what language you speak.
That's true. That's true. But what we're looking at here, I mean, how far back for either of you might have been that Mars, that watery, cloudy Mars that someday we hope we'll find out if there was stuff swimming around in those seas?
Well, first of all, I have to scientifically say not everyone accepts this.
It's a fanciful representation.
But it's getting more and more people on the side of an ancient Mars ocean, still a bit debated. But you're looking really far back. Maybe Emily has more insight, but I mean, you're at the 3 to 4 billion years back type range before we think something happened. But that's part of what's exciting about MAVEN, is by understanding how rapidly atmosphere is lost and what's coming and slamming into it from the sun to make it get lost, we'll hopefully get a better estimate of when you might have had a thick atmosphere on Mars.
Emily?
One of the things that's really changed in the last 10 years of studying Mars from orbit is that we've long had this idea that Mars used to be wet and now it's dry. There's plenty of evidence on Mars for these river cut channels, some with gigantic outflows of massive catastrophic floods, and others that are just smaller networks of valleys, more like we have on Earth. And we've had this idea that Mars was wet and now it's dry. There's actually a slightly more complicated story coming out of the orbiters these days, where Mars actually started out dry and got wet at about 3.8, 3.6 billion years ago. I'm not sure how much I believe those precise numbers, but the point is that it was dry, it got wet during a period when the atmosphere was a little bit thicker, and then it got dry again. And so we're beginning to get a more complicated history. And then it's getting even more complicated because we have enough orbiter data now that we can look very closely at little spots on Mars, and we're finding that Mars's geology is, surprise, just as local as Earth's geology is. So everything wasn't the same in all of the places on Mars at the same time. And the more we study Mars, the more complex the story gets, which of course is nice job security for scientists.
Yeah, that is the general theme, and every time one comes up with a simplistic explanation or hypothesis for Mars, you get better data and realize that everything's more complicated, kind of like all real worlds than we first suspected.
But this mission really is filling in a big hole in our data, our knowledge, right?
Yeah, this is really one of this is addressing one of the big science questions of Mars, which is what happened to that presumably thick atmosphere early on, and is that a valid theory that it had a thick atmosphere and that's what kept liquid water stable on the surface? The background we should probably mention right up early on is that liquid water is not stable at the Mars pressures right now. So liquid water on Mars acts like dry ice or carbon dioxide on Earth. It's either a solid, it's either an ice, or it's either a gas. It goes back and forth between those two states, except possibly for very brief periods of time that you might generate tiny bits of liquid water. But by and large, it's not stable. So that's why when we see lots and lots and lots of geologic evidence from orbit, evidence from rovers, all indicating that there was lots of liquid water in Mars's past, even stable in the environment, that you raise the big question: how is that possible? What was different? How is it possible? And one of the main theories for this that MAVEN is specifically designed to explore is that you did have a thick atmosphere on Mars generated by things like volcanic activity, but then that atmosphere was stripped away, particularly after Mars lost its global magnetic field. On Earth, the magnetic field helps protect us, shield us from charged particles coming in from space. On Mars, you've lost the global magnetic field, and so you tend to strip off. You have solar wind particles come in, and they slam into things in the upper atmosphere. They kick them off. There are other ways you can lose it, too. It's a more complicated thing we can keep going into as the day progresses.
Well, speaking of which, Emily, what about the thought that a lot of that water, that missing water, is still there, but below the surface?
Well, there's a lot of places on Mars, actually, that there's still water. And the simplest one to see, you can actually see in a backyard telescope, is the ice caps. There is water. There's frozen water on the surface of Mars near the poles. Those polar caps actually go quite a bit underneath the surface of both ends of Mars, so that if you dig just a little bit below the surface layer of dust, you get to a pretty thick layer of surprisingly pure water ice buried just below the surface. We saw it with Phoenix. Phoenix managed to dig down and expose that ice. Evidence suggests that Viking 2, Viking 1, which one landed farther north? I always forget.
Viking 2 was
Viking 2.
Like 48 north latitude.
Right, so and evidence suggests that if they had dug 10 centimeters deeper with their trenching tool, which they could have, they may well have found pure water ice there as well.
Almost 40 years ago.
Almost 40 years ago. So there is actual water ice right below the surface. The blue clouds that we can see, the blue white clouds that you can see on Mars are made of water ice crystals. And a great many of the minerals on Mars contain water, either water molecules or the hydroxyl ion, the OH minus ion, bound in their mineral structure. So there are a lot of places on Mars where there is water.
Yeah, there are two very closely related questions going on here. One, what happened to the atmosphere? And two, what happened to the water? And MAVEN particularly focuses on what happened to the atmosphere.
Tell us about this mission. Well, actually, I'll hold off on that. We got another launch to show off to people. Emily, were you going to jump into something else first?
I just thought I would give a quick update and say that the liquid oxygen has been loaded into both stages of the Atlas and the Centaur, and they're topping off the liquid hydrogen right now. So we're getting under about 40 minutes to launch, so we're getting pretty close.
All right, as it stands now, those of you sitting here with us, we have been looking at the opening of the launch window, which is the target for launch at 10:28 a.m. Pacific time. Now, we know that many of you are listening across the world to the live webcast of our program today. You can figure that out for yourselves. But right now, it looks like everything is go. And Emily, I think the last report was that the weather still looks good too.
Yeah, the weather is currently green. One of the things that they're worried about is clouds drifting through. There are cumulus clouds. There could be lightning concerns. And so they're actually talking about how the weather may go red and then green and then red and then green, and they may have to pause and then say, okay, now it's green, go. So we'll have to see how that goes. I did just see on Twitter under T-29 and now a new concern for a Centaur valve sensor.
Uh-oh.
So we're going to have to keep on top of these sort of things. But I'm watching Twitter and Spaceflight Now, which does a tremendous job of keeping up to date with their website. So I'm going to keep my eye on that and see how it goes.
Bruce, tell us about the rocket that's going to start this journey to Mars. This this mention of a Centaur and a possibly sticky valve.
Yeah, the Centaur is a mythological creature they put on top of the Atlas rocket. No. This is an Atlas rocket, so that takes in the lower stages, but it's got, and one of the upper stages is a Centaur upper stage. Obviously you need, it's the challenge with space exploration, you need everything to work. And so if you have one sticky valve one place, that's a bad thing and is enough to delay launch if they can't make themselves happy about it. But it's an Atlas rocket without the, it's a big rocket that's in a slightly smaller configuration, Atlas V, than the usual or other Atlas configuration. So it doesn't have strap-on boosters and things that were used for, say, Curiosity's launch. But big, complicated rocket.
And I can say that we have permission from our hosts, Southern California Public Radio, to stick with this, even if it looks like the launch is only going to be delayed a few minutes. We can probably stick around, maybe a half hour later, but we won't have all day. So there is the strong possibility still that you'll have to pick this up on your own from home. But we sure hope that we can all enjoy this together.
Their launch window for reference is about 2 hours, so they need to get it off within 2 hours of the opening of the window, otherwise they move to tomorrow.
Which sadly is beyond our launch window here. Emily, there is another mission that I mentioned at the outset that is on its way to Mars right now. Here's a picture of that launch taking place, and it took place from somewhere where people may not be used to interplanetary missions.
That's right. You're looking at the 25th launch of the Polar Satellite Launch Vehicle. That's the Indian Space Research Organization's main workhorse launcher. And they launched a spacecraft into Earth orbit that's going to be going on its way to Mars very soon. The PSLV is not powerful enough to launch on a direct to Mars trajectory, so they had to launch into Earth orbit first and do what are called phasing loops. They pumped up the orbit a total of 5 or 6 times, I think it was 5, in order to slowly increase their apogee from Earth, getting farther and farther until they can do one last kick that'll finally escape Earth's gravity and get them on a heliocentric orbit and transfer to Mars. They will wind up being on the path to Mars and basically the same trajectory and time frame as MAVEN. They're both going to be arriving at Mars within a few days of each other. The Indian mission is going to be departing Earth orbit on November 30th.
And right now, status is good. I know they had a little bit of a challenge early on.
They had one problem with one of their orbit adjustment maneuvers, but they seemed to understand what the problem was, and they were able to rectify the shortfall in their orbit with a supplemental burn. So they're They're basically on their way. They've completed all of the phasing loops, and now they're checking out their instruments. I'm hopeful that we'll actually see a photo from their camera. I've heard rumors that we're going to see that. I'm not sure if they'll manage to accomplish it, but they'll check out their instruments in Earth orbit and then depart for Mars at the end of the month.
And so what is this spacecraft hoping to learn at Mars?
Well, this spacecraft has it's called the Mars Orbiter Mission, which they abbreviate MOM. It has a very small payload, about 15 kilograms. By comparison, I think MAVEN's is 70 something. Yeah, so it's basically a weight is a pretty good proxy for the capability of an instrument package. This mission, as far as I'm concerned, the Indian one, is really about demonstrating and testing all of the new capabilities they had to develop in order to go from a nation which has a lot of experience launching and operating spacecraft in Earth orbit to one that can operate deep spacecraft. There's a number of different things you have to do. You have to be able to build a spacecraft that's smart enough to operate autonomously and respond to anomalies intelligently. You have to have a spacecraft that can handle not being in constant communication with Earth. You have to be able to handle this time delay of communication. The spacecraft has to be able to point very accurately at Earth in order to maintain that radio link. And they're going to have to operate their main engine after a year of it not being operated. And they only get one chance to enter Mars orbit. So it's going to be very interesting to see if they manage to do all that. They have an instrument package that, among other things, has a methane sensor. Which is looking to answer this question of, is there actually methane in Mars's atmosphere? Curiosity has looked and found none to its detection limits, but Curiosity is in one spot on Mars, so it's possible that the Mars Orbiter mission may see something that Curiosity didn't.
And you're kind of getting used to calling this mission Mom, aren't you?
Well, they really are buying into the name, and they've written poetry. They posted it on their official website about, saying goodbye, sending their mother off to Mars. So I guess I'm going to have to get used to it.
And I think we're going to come back to that during What's Up today. Bruce, tell us why it's no accident that these two missions left about the same time.
The way orbits work is it's much easier, much easier if you launch to Mars during what they refer to as a launch opportunity, and those come around for Mars, the way the Earth's orbit and Mars's orbit interrelate, every 26 months. And so about every 2 years is when you have a good chance to launch to Mars, and if you're a nation or agency trying to launch to Mars, that's when you're going to do it.
Let's talk about what's happening at Mars right now, the spacecraft that are there, beginning perhaps with the one that has excited so many people over the last more than a year now. There's Curiosity, artist rendering, of course, happens to be firing. You can just barely see it there. It's firing the ChemCam, the ray gun that we sent to Mars before they could send one here. Just give us an idea, both of you, but Emily, you first, about where Curiosity is and what it's up to.
Well, Curiosity is inside one of the deepest holes on Mars called Gale Crater. Gale Crater is an impact crater that just happened to happen on what's called the dichotomy boundary. This is where Mars has the southern hemisphere of Mars is very high elevation, ancient cratered terrain like the moon. The northern hemisphere of Mars, more or less, is much lower elevation and is much smoother. There's evidence of geologic activity there much more recently. The Gale Crater happened right on the boundary between these two. And a lot of water appears to have flowed from the south toward the north, and there's good evidence that water pooled in Gale Crater at different times. Gale also has this central mountain in the center that appears, at least the bottom part of the mountain, is made of horizontally layered sediments. And we've seen from orbit that these sediments have different compositions. In some places they're clay, in some places they're sulfate, some places we can't tell. But all of these layers seem to have been formed in different chemical environments. So by looking at those layers of rocks in the mountain, we should be able to understand this Martian story of how the environment on Mars changed over time. Now, Curiosity couldn't land on the mountain. We don't yet have a spacecraft that can steer to a perfect point landing on any kind of challenging landscape. So we had to land Curiosity in a flat place. And flat is relatively boring geologically. Curiosity has seen some cool stuff, but Curiosity has not seen the rocks that she was sent to Mars to look at yet. So she's initially tested out her instruments on the rocks that are on the floor of the crater and seen some really cool stuff like fluvial conglomerates on Mars, which means there were rivers running through this landscape, which is cool. But she now has to drive a very long distance in order to get to the mountain. The total drive length was about 9 kilometers. She's accomplished about 4 of that so far. So it looks like we're on track for Curiosity to arrive at the mountain in about sometime next summer. And one of the cool things that the Curiosity mission just did was to name the first spot on their approach to the mountain for Bruce Murray, who is, of course, very special to the Planetary Society. So now their entry point into the cool rocks is a place called the Murray Buttes, and those will be the first section of those rocks that Curiosity is going to be studying.
Pretty meaningful for you, Bruce. I mean, he was your mentor, Bruce Murray.
Yeah, very meaningful, very nice. Bruce Murray was my PhD advisor, mentor, friend. It was sad to see his passing in August, and so it's nice they've named the Murray Buttes, where they'll dig into geologic action. And I've been on Bruce Murray geology field trips, staring at cliffs and road cuts and things geologists love, and that's what they'll be doing at the Murray Buttes. Opportunity, they also named where Opportunity is right now, Murray Ridge in his honor, so it's nice.
And since you mentioned Opportunity, we should talk for at least a moment or two, just summarize the other missions that are at Mars right now, orbiters and that other little animal on the surface that's going to be celebrating 10 Earth years on Mars in just a few months.
Yeah, Opportunity doing great, as you say, 10 years. They always tout, they promise 90 days, and they've gotten 10 years out of it. Emily can give us probably better updates than I of what it's doing these days, but it's actually climbing hills like its sister spacecraft Spirit did during its period, and hanging out at Murray Ridge, doing great. In orbit, we have 3 different orbiters. Mars Odyssey, been there since 2001, still giving us great coverage of the surface. Mars Express, from the European Space Agency, also doing great stuff orbitally since 2003, I guess. And then Mars Reconnaissance Orbiter, complete with big giant camera, is hanging out since 2005. All of them doing great stuff and providing a nice, it's just a very nice combination package. And you can compare and contrast and complement data from one spacecraft, one rover. You can mix them together. You get ground truth, you get global coverage, and now with MAVEN we'll get something we haven't had, which is an orbiter looking at the real upper atmosphere. I mean, so upper that many of us wouldn't even think of it as atmosphere, but one person's space is another person's upper atmosphere.
Not down in the nice thick atmosphere at the surface of Mars. That's
exactly.
Speaking relatively. Emily, it's the Mars Reconnaissance Orbiter, that big eye on there, HiRISE, that has given us so many amazing views of Mars, including the landing of Curiosity. What's its resolution?
It can achieve close to 25 centimeter resolution. So if you think about that, that's the size of a man's foot. So you can basically create hiking maps on the surface of Mars thanks to the wonderful data from the HiRISE camera on the Mars Reconnaissance Orbiter. I do want to interrupt to give an update on the launch status. We have tanking is complete. Everything continues to move forward. That valve issue that they were working appears to have been cleared. So far so good. And we're looking at now about 25 minutes to launch. So everything so far so good.
And we are looking at checking in for the first time with one of our correspondents in Florida. And I believe it's Casey Dreyer. Casey Dreyer is the Planetary Society's advocacy and outreach strategist. He is in Florida, as I said. He's at the Kennedy Space Center. Casey, if you can hear me, good morning, or in your case, good afternoon. Hello, Casey.
I am calling in, and it looks like I'm just coming on the video.
We can hear you.
Okay. Which would you prefer me to use, the video or the phone?
Let's stick with the video. Let's go with FaceTime.
Okay.
Little ad for Apple here. So it's slow scan because, as you might imagine, there are a lot of people using their 3G connections right now at the Kennedy Space Center. But we're going to stick with this because the audio is still a little bit better. If we have to, we'll fall back to a phone conversation with Casey. So Casey, tell us what's going on.
Hey, Matt. Well, we are standing here. I'm standing here with Planetary Society President Jim Bell. And we are waiting with great anticipation for the launch today. The clouds are starting to come in, and so we're a little worried about the weather at the moment. Maybe I can pan up and back here. The VAB is looking beautiful.
Uh-oh.
And Looking great.
We're breaking up a little bit here.
You can see there. Oh, there are relatively large clouds coming in. For breath.
Yeah, unfortunately, Casey, it froze on you, but we can still hear you more or less.
Okay. So I also have Jim Bell here, and we're just kind of waiting. There's not much we can do. Luckily, in some way, the clouds came in and took the sun off of our shoulders, and it was a pretty brutal morning here. Well, most of us ran into the Saturn V Center in the air conditioning, and we just had to suffer standing underneath the Saturn rockets. So
good old Florida.
We're somehow surviving.
Listen,
Yeah.
Do you think we can say hi to Jim for a moment? If so, I'll introduce him.
Absolutely. Would you prefer video or audio for him? The FaceTime or the phone call?
Let's stick with the FaceTime for now. The audio quality is still better. I will tell you folks, you already heard that he is the president, actually the president of the board of the Planetary Society, but Professor Jim Bell is also an astronomer.
Hey, Matt, can you hear me?
I sure can, Jim. I'm introducing you. Hi.
Hey there.
It's great to see you.
Oh, sorry.
I'm glad you're dressed appropriately for Florida. So I'm going to finish your introduction.
Here, man.
He is an astronomer and planetary scientist in the School of Earth and Space Exploration at Arizona State University. He blogs now and then for the Huffington Post, and if you haven't checked out his gloriously beautiful books, they include Postcards from Mars, Moon 3D, Mars 3D, and Jim, I'm reading the newest right now. It's simply called The Space Book, and it's why I like to call him the Ansel Adams of Mars, because he loves to take pretty pictures up there. Jim, give us your sense of what's going on there. I mean, you've been to launches before. Is it still exciting?
Very exciting. This is actually my MAVEN Mars launch. I've been very, very fortunate to be involved in a huge number of these robotic missions. There's something very, very special about launch day, about the opening of the launch window, which happens just in a half an hour or so from now, a little bit less. It focuses your thoughts. It focuses you on the success of the mission. It comes down to this point right now. Looking around here, there's all these folks in red shirts. They're MAVEN science team members, engineering team members, launch crew, their families, their kids, and this is what they've been working for. This is the first critical event, maybe the second critical event. The first critical event was getting selected back in 2006. They won a competition to do this mission, beating out 10 or 20 other mission proposals for the privilege of sending their mission, doing their science at Mars. And so that was the first hurdle. Now this is the second hurdle, getting everything that they've been working so hard for, sitting on top of this controlled bomb that's going to be launched off this planet as soon as we possibly can. So it's very, very exciting.
Jim, I want to ask you a question that I already threw toward Bruce and Emily here, and that is where this mission and what it hopes to learn fits into the body of knowledge that we have built about this planet that you've been living and breathing for so long.
Yeah, no, that's a great question, and for me, it has sort of two main places that it fits in. We've been focusing a lot on the surface with Mars Pathfinder, with Phoenix, with Spirit, Opportunity, Curiosity, the InSight mission coming up in 2016. Getting to know the geology, the past history of the planet as recorded in the rocks and minerals. Doing some of that from the orbiters as well, looking down at the surface with Mars Reconnaissance Orbiter, with Mars Odyssey Orbiter, with the Mars Express Orbiter from Europe. And now this mission is entirely focused on the atmosphere. What is the current state of the upper atmosphere? And are there clues in that atmosphere that tell us about the past? We hypothesize that the atmosphere was thicker in the past, that there was more carbon dioxide, that there was higher temperature, higher pressure. Where did all that gas go? Where did it escape to space? Did it seep into the rocks below? MAVEN is designed to test that hypothesis. So that's one main aspect, the science side of it. And then maybe not so well considered other aspect of this mission that I'm most interested in, because I'm not involved in the MAVEN science team directly, but I'm very interested in that when they complete their mission, when they finish their primary mission, after an Earth year or perhaps even a Mars year if they get an extension, they'll change their orbit into a relatively circular orbit and act as a communication satellite, a relay satellite for the missions that are down on the surface. We don't know how long Mars Odyssey and Mars Reconnaissance Orbiter will last. Opportunity is still working. Happy Sol 3490, by the way, of our 90 Sol mission on Mars. Curiosity is going great, 454, 55 Sols in to its mission. But those missions need the communication satellites, what MRO and Mars Odyssey are doing to get those bits back. And MAVEN will become the newest communication satellite after their primary science mission is completed. So, those of us who are working with surface vehicles are really hoping for their great success in their atmospheres mission and hoping for a long life for their spacecraft to help us get all those pixels off the surface.
Jim, we only got another minute or two before we check in with the CEO of the Planetary Society, Bill Nye. Just tell us, what should be next on Mars? Assuming MAVEN goes and does exactly what it's intended to do, what would you most like to see in upcoming missions?
Well, that's a really good question. I was an advocate, along with some other colleagues, for sort of cluster bombing the planet with Spirit and Opportunity class rovers and really doing those kinds of detailed investigations at 5, 10 other sites. The landing site selection process identified a huge number of places to go on the planet that are going to tell us about the ancient history of the planet. But that path is not being taken. Instead, what I think is the next logical thing to do is what NASA is right now planning, which is what the Decadal Survey calls for, and that's the start of a sample return mission. So the Mars 2020 rover will cache some samples, store them on board, leave them somewhere known, and hopefully a future mission in the 2020s can go grab that cache and bring those samples back to the Earth. I think that is the next step. It's what the community wants. It'll be publicly exciting. It'll be scientifically incredibly compelling.
Jim, we are going to break away because we are going to try to check in with Bill Nye. And at this point, we are just over 15 minutes away from launch. So,
all right, go MAVEN.
Go MAVEN, absolutely.
Go
Best of
Atlas
luck to all you
Centaur.
guys. Jim Bell and Casey Dreyer of the Planetary Society, everyone. Take care.
Thanks.
And if I can give an update, they're doing the final polls. Launch vehicle green, range green, spacecraft green. Everything is green, and they're headed toward launch at 10:28 our time.
Absolutely great. I want to hear a little bit more about this 2020 mission and why it's important to go there and grab a sample. And Bruce, I wonder if you would start with that. And while you're doing that, I have to call the boss. I have to call Bill Nye.
It's not just the radio show. Matt has to do this about every hour, every day. Well, Mars 2020 mission is structurally, it's the Curiosity rover again, but they're competing the science instruments separately, so you may end up with a different package of science instruments, but it's the same chassis and power and communication, things like that. And then as part of this, they're supposed to grab samples and put them in a cache. So store them for an unknown future return so that something else could go down, pick them up, return them to Earth. This is awfully challenging, awfully expensive to do Mars sample return. Why would you want to do that? Well, because no matter how advanced our instruments get going to Mars on the spacecraft, and they are getting much, much more capable, and things are getting into smaller packages so you can send them. You still have capabilities on Earth where you can use as many instruments as you want, large instruments, and you can do very precise measurements. Lots of scientists can participate with any given set of samples, and you can actually sample things in a geologic context, where they came from, what environment, and then study them in detail in the laboratory, and hopefully from that gain much greater insights about Mars than you would just through rover instruments or through using the Mars samples we have already, which we do have from meteorites. Problem is we don't know their geologic context and where they came from.
Thank you so much. Here was the deal, folks. Bill asked us to call him on the phone before we try to reach him via FaceTime. And Dave, he's ready to go. So we're going to try and bring Bill up here. He's a little concerned because, of course, we are now 14 minutes away from launch. And so we're going to see if we can pull him up here just for a couple of minutes to get his viewpoint. Now, Bill is in a different...
Yeah,
there he is.
Put you on big noise.
Ladies and gentlemen, the CEO of the Planetary Society, Bill Nye, the science guy. Hey, Bill.
Greetings, everyone.
So where are you?
I'm on the balcony of the operations building at Kennedy Space Flight Center. Let me see if I can find my finger in the frame. There is the MAVEN rocket, an Atlas Centaur with the MAVEN spacecraft on top. And we are going to leave the Earth here in, I guess, 18 minutes. That is if, as the saying goes, nothing don't happen.
Less than that. We make it 13 minutes, but so it's even
So
tighter.
there's a 4-minute hold. Don't kid yourself.
All right.
I think there's a 4-minute hold built in, but this, they didn't put me in charge of this, but it's going to be spectacular. Now, I just warn everybody who's watching this thing, it'll go really fast. This one is not going into orbit around the Earth at all. It won't go over the top. At least, I don't think it will. It's just going to...
Fingers crossed. Yeah. Listen, you don't know that we just got off of FaceTime, got off the phone with Jim Bell and our colleague Casey Dreyer, who talked about why they're so excited about this mission. Is this just another Mars mission to you? I kind of doubt it.
What? What? How can there be such a thing as just another Mars mission? No, it's very exciting. I'm thrilled. See, the whole thing, everybody, let's say there's two things. We want to know what happened to the climate on Mars so we can learn about the climate on Earth. I mean, that's for one thing. And this mission will help us learn about what happened to the atmosphere of Mars, and especially the water that used to be there, which almost certainly became part of the atmosphere and got blown off into space, probably by the solar wind. But we're going to go have a close look. And then the other thing I remind everybody, when we have a space program, it just raises everybody's expectations about everything. It helps us think that we can solve any technical problem because we can put a spacecraft in orbit around Mars. And let me emphasize, around Mars. It's so far away. You got to go like 35 kilometers a second to get there. It's astonishing. And we will use the motion of the Earth to give us a boost. And from my vantage point with human eyes, I can see the venting of the liquid oxygen tank, but I don't know if you can make out that much detail on this little camera.
No, not quite.
It's exciting. You can feel it.
Tell us a little bit about where you are on the. Tell us a little bit about where you are. We have a great view of your ear, by the way.
Yeah, well, we are trying to hear us. So there's the vehicle assembly building.
Uh-huh.
And each star on the flag is about 2 meters across, about as far across as I am tall. And then here's the operations. What's that? They all have fabulous acronyms. Dr. Betts probably knows that one. It's the control center for launch control center. And then this building is the operations center, and then we have a big crowd out here getting ready to watch. And out there is the rocket in that brown stack, and it's surrounded by 4 lightning rods, or they have a fabulous acronym also, but lightning suppression system. And the clouds are coming in. I'll show you some clouds. But I think we're going to punch through that hole, and we'll make it. Because we've only got, what did you say? I think we have 12 minutes. It might be 10 minutes, yeah.
Yeah. Let me open this up to Bruce and Emily as well, Bill, and see if they have any questions for you.
Yeah, here we go. We'll watch.
Here's Bruce.
How's the weather, Bill?
It's in the 28 Celsiuses, the 80s Fahrenheit, and you're going to be shocked to learn, Dr. Betts, it's a little bit humid.
Really? In
so seldom
Florida?
that way in Florida, yeah.
Yeah.
Yeah. So the humidity makes this layer of ice on the rocket as they load the cryogenic, the cold hydrogen and oxygen. The rocket gets this coating of ice. And I guess when we first start launching, this is sign language for first launching, the ice shakes its way off on the way up.
Bill, I want to give you a chance to talk about why missions like this and others that are already on Mars are so important to the Planetary Society, and why people like our colleague Casey Dreyer and you are working to protect them.
Well, the more we know about Mars, the more we'll know about ourselves. And Mars is the most likely place at our current level of understanding of astrobiology to find evidence of life. And my friends, to me, to my little brain here, it is quite reasonable that there be a place on Mars, I'm imagining near the equator, with some subterranean, some underground ice that gets warmed into some super salty, slushy mix in the summertime, and there's some crazy Martian microbe still alive there. Cannot prove it unless we go have a look. But it does not seem, it seems extraordinary, but not incredible to me. So if we found life on another world, and the cost of these missions is so low compared to what we spend our money on. The Planetary Society, we advocate for $1.5 billion a year for planetary science. In contrast, the space shuttle, which was assembled in the vehicle assembly building and is represented by this workout track here on the field in front of this building, those missions cost $1.5 billion each. And the current number that NASA likes to throw around is $3.60. So for every dollar we spend on space exploration, we get $3.60 back in investments in innovation in our economy. But I suspect it's quite higher than that because of this, what I like to call the spiritual aspect of it. That is to say, we have this expectation that we're going to solve technical problems, that the future will be better. And there's nothing that gives us that like the space program. So it's an exciting day, and Mars is part of our heritage as Earthlings in the solar system, and the more we can learn about it, the better. And the MAVEN mission is extraordinarily low cost for the potential scientific return. I'm going to bring the phone back near my ear again.
Okay. Bill, you are not alone in that excited crowd there. We have a lot of people here in Pasadena at Southern California Public Radio who are also thrilled that in just a few minutes here we may be seeing this launch of the next mission to Mars. Thanks so much for joining us. We're going to switch over to NASA TV in a moment. I hope everything continues to be go, and Bill, thanks for talking.
Thank you, Matt. Our mission at the Planetary Society is to advance space science and exploration for all humankind. The world's going to be better for it. Thanks, everybody. Thanks for your support.
Take care. Bye-bye, Bill. Bill Nye, CEO of the Planetary Society. We're going to check in with NASA TV beginning in just a moment here to go to the live coverage. But first, Emily?
They have conducted the final launch poll. Everything is go for launch.
Yeah.
Woohoo.
Absolutely. And let's do this again when we see that Atlas V lift off. Yep. Any other comments from you two before we go over to NASA TV, and then we will add some commentary as that's taking place?
Nope.
Let's
go
do
over
it.
Let's listen to the commentary.
We can
There we
talk
go.
more MAVEN when we get a chance.
So while we wait for NASA TV to come up in here, we'll just remind everybody who's out there watching the webcast that we are at the Crawford Family Forum here at Southern California Public Radio, KPCC radio for Southern California. And we are the Planetary Society. Our hosts, once again, SCPR, helping us produce Planetary Radio Live. Thought I heard it there for a moment. Should be coming up here any second, I think.
He won't be talking continuously.
No.
So
there is our first really good view of this Atlas V with its priceless payload up there on the tip. And it looks like a freeze frame, actually. I don't see that liquid oxygen steam doing anything. Okay, we should be coming up here in a minute. Bruce, you want to tell us a little bit more about what we see here?
Those towers on the sides are, especially because you're in Florida, are lightning rod towers. Make sure you don't hit the rocket. You got the Atlas rocket in the center with the Centaur stage up towards the top. A lot of liquid fuel filling it, and the fog coming off because you're using cryogenic propellants, things that are liquid hydrogen, liquid oxygen that are extremely cold, and so therefore that cold gas hits the Florida atmosphere, and you get condensing fog coming off of there. Looks like they still have some umbilical cords wires headed to the rocket, so they'll keep it on, make sure they can feed power and communication for as long as possible, but then they'll pull those away before launch when they really think they're going. They've already switched over to internal power, but they keep the umbilicals on there as long as they can. I guess we're the spinning circle in the middle of the frame is...
I've never seen that on a rocket.
Yeah, that's a new improvement on the latest version of the Atlas V, has the spinning circle. It's mostly for the public.
There are no people anywhere near this rocket right now, right?
We hope not. No, they clear the area. You could tell from Bill's footage that even when you're at the super VIP area to watch it, it's measured in a mile or two. I forgot the range, but a couple miles, 2 or 3 miles away, because it makes a big ball of flame. Even when it works right.
They have picked up the launch countdown. They've ended their 10-minute hold. They're now in the final 4 minutes. I also understand that many people are having trouble with the NASA TV feed and are switching to their Ustream feed. So.
Oh no! Well, guys, there's a word to the wise.
Yeah, Spaceflight Now.
You have it on Ustream there, or Spaceflight on Spaceflight Now.
Even
all right, we'll see if we can bring that up before the launch. And for the sake of these folks over here from KNBC, we didn't do this for Laddie, but let us know how you feel about this when that big rocket takes off. That emotional reaction, I think, will be very welcome and very appropriate. All right, while we try to get that signal, and we still have a couple of minutes to try and pick it up here, as we go to the Spaceflight Now website and see if they're doing any better than NASA is directly. Understandably, there are a lot of people tuned into this stream from NASA. Do you have another update, Emily?
T-minus 2 minutes. Everything's headed to launch.
Okay.
So if we get a launch, if anyone's willing to do weeping, that'll probably play well.
All right, let's see. I think we may be live. Oh no, that counter's not moving. They're either in a hold or we're frozen again.
I think I got it. I think I got it on the TV here.
Oh, okay.
All right.
140.
Minute 40? Boy, this is going to be nip and tuck, whether we pull this up live.
Launch enabled. FTS
There
armed.
we go. And the timer is moving. I think we got it up here.
T-minus 90 seconds.
All right.
110.
Now, I think
120.
Vent valves locked.
Orca's armed.
FTS count started.
we're not going into orbit, right? This is straight for the red planet?
1 minute.
Rock report range status.
Yeah, although
Range
they're
green.
spending some time around Earth, but basically you're doing stage,
110.
stage with gaps in between.
Vent valves locked.
Standing by for final Atlas and Centaur go.
1 minute.
So they
Rock
could
report range status.
40.
Range green. Stable at step 3.
they could still call this off.
Standing by for final Atlas and Centaur go.
40.
Stable at step 3.
40.
Stable at step 3.
And we have it on the big screen. 30 seconds.
25.
Status check.
Go Atlas.
Go Centaur. Go Maven.
Go Atlas.
Go Centaur.
20.
Go Maven.
20.
Shall we join the countdown? Give it to us
15.
live when we get to 10.
15.
T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Main engine start, ignition, and liftoff of the Atlas V with MAVEN. Looking for clues about the evolution of Mars through its atmosphere.
Go Atlas, go Centaur.
Go Maven!
Everything looking good. Still at 100% rated thrust on the RD-180. Vehicle rates are looking good. We do have roll program in, right as expected. We are actively controlling mixture ratio. Valve position looks good. Thrust
Always
regulator valve
exciting,
position looks good.
always scary
Speeds
as
are
hell.
good. And vehicles operating as expected. Continue down the center of the range track. Everything is looking good.
Emily, do you have any news?
1.6 nautical miles of altitude, 1.1 miles downrange, traveling at a little over 1,000 miles per hour.
This Atlas does not have any strap-on boosters, unlike most of the other Atlas launches you may have seen in the past. We've just got one main engine.
Y'all roll programs. Everything is looking good, continuing at 100% thrust. Looking good, continuing at 100% thrust.
Probably got lost in the clouds, which is why they will have switched to the computer animation.
The Atlas engine will burn for a total of 4 minutes before it burns out.
Rated thrust. Continue to operate at 100% rated thrust. We're about to pass through max Q.
Bruce, in some ways, is this the toughest part of the journey for MAVEN? I mean, just in terms of what it has to go through?
Certainly environmentally, other than vacuum and space type things. And they shake everything on board this before you fly anything on a rocket. They're subjected to vibration tests to make sure you're not going to shake anything free.
Can you bring the NASA back up?
And everything is looking good. Continue to operate at 95% thrust.
We're now 2 minutes post-launch. Got another 2 minutes to burn.
Coming up on our next mark event, I expect to enable Q alpha steering. And steering's enabled. Body rates look as expected for bringing in steering. Vehicle is now 50% of its liftoff weight. And we're about to fire the pyro valves to activate the second stage reaction control system. Pyro valves have fired. System has pressurized. And the RD-180 continues to operate as expected at 100% rated thrust, or 95% rated thrust, correction.
Bruce, that was a fascinating
Rates
statement.
are looking good. Continue to accelerate, passing through 3 Gs.
2 minutes, half the weight gone.
PU control looks good.
Rocket science, it's a trip.
And continue to fly right down.
Yeah,
We're now coming up on 3 minutes post-launch. At 4 minutes, the Atlas is going to burn out. 6 seconds after that, the Centaur will ignite. It will burn for a total of 9 minutes, and the fairing will jettison in the first few seconds after Centaur ignites.
Reaction control
So where'd that weight go?
Pressurized.
It went out the back of the nozzle after combustion, and that's what threw your rocket forward.
95%. Good PU control.
And the fairing that Emily referred to is the cover over the front of the rocket. Once you get high enough above most of the atmosphere, you can get rid of that. You don't need the atmospheric streamlining.
Control at 5 Gs. We have started boost phase chill down. Housing temps are reacting as expected.
We're very close
Continue
to
operate the
separation here,
RD-180 as
Emily.
expected. We are now flying a 4.6 G throttle profile. Engine is throttling, getting ready for booster engine cutoff. We have BECO
Booster engine cutoff.
coming up on staging. We have stage separation.
Woo! Go Centaur!
Everything is looking good.
All right.
Pre-start on fuel and locks.
And there's the Centaur engine, at least in the
Ignition,
animation.
full thrust. Centaur main engine is up at 100% rated thrust, coming up on fairing separation. We have fairing set.
Fairing SEP, so now the spacecraft is seeing space for the first
Rates
time.
look good for fairing separation. Should be cutting back in on closed loop control. And we've done purge firings in the reaction control system as expected. We do have closed loop control reestablished after fairing jettison. The RL-10 continues to operate as expected, nice and smooth. PU is in open loop control as expected.
Do either of you know at what point the spacecraft will separate
Axial
from the
acceleration
Centaur
is
booster?
steady.
So the Centaur is going to burn for a total of 9 minutes, and then
Right
the
now,
spacecraft
93
coasts for
or
28
107
minutes
miles
before
at
reigniting for another 5-minute burn.
426
And then
miles downrange,
separation will happen
traveling
after that. So
11,000
it's all going to be over and on its way to Mars
700
within an
miles
hour
per
after the launch.
We'll stick with
Vehicles
this for another
continuing
minute
down
or
the
two.
Center of the range track. Everything looking good. We're seeing our expected thruster, reaction control thruster, thermal maintenance firings. Body rates are nice and smooth.
I love rocket terminology.
Everything is continuing to look good. Engine operating parameters are good.
So maybe we can, Dave, if we can keep this video up, but take the
We are
audio
now
down.
in the
And we'll
process of
continue with our
executing
program here. Maybe we'll
8-9.
check in a little bit later as we keep an eye on things. And Emily will continue to monitor the mission status for us online as well. But we have a few more things we want to talk about. Emily, I want to start with a question for you, because you brought this up just, I don't know if it was last week or the week before, on Planetary Radio. And it was that image of that cowl that we just saw separate in the animation being locked down over the spacecraft. And that's a big moment for the people who put this thing together for so many years.
Yeah, it is a big moment. That when they enclose the fairing over the spacecraft before they put the spacecraft on top of the launch vehicle. So basically, they get the spacecraft all wrapped up and ready for launch, and they put it inside the fairing, and then they go take it to the launch site and lift it up to the top of the launch vehicle. So enclosing the spacecraft in that clamshell, that's the last moment that human eyes will ever see this particular spacecraft. It's really true for orbital spacecraft. Maybe for the landed ones, one day there might be human eyes back on Curiosity and Opportunity. I'd like to think that. But spacecraft like this one is going to end its life eventually in a fiery burn-up into the Martian atmosphere. So that's the last time human eyes ever looked at it. It's definitely a bittersweet moment for the people who have spent so many years preparing it for launch.
All right, so Bruce, assuming everything in the next few minutes goes well, it's now in the vacuum of space and has a good long while before it reaches the red planet.
Right. Gets there in September of 2014. Has various orbital burns, taking it into orbit and then modifying the orbit. It's got kind of an interesting orbit due to the nature of what it's doing, trying to study the upper atmosphere. It's very, very elliptical early on during its science phase. So it comes down to about 150 kilometers closest to the planet, so whatever, 90 miles or so altitude. But then it goes out to like 6,000 kilometers. So it's in this very thin ellipse for the duration. And it actually does what they call deep dips, where it takes a bit of chop, puts it between its solar panels. No, hopefully the young youth don't even know what that means. It takes and it dips its periaps, its lowest point, even lower to like 125 kilometers. So it has a variety of instruments on board, most of them fabulously complicated, some of them actually sample the atoms, the ions.
Taste the atmosphere.
They taste the atmosphere, and they taste it better when they dip farther down. And so they're tasting what's leaving the atmosphere and what's high up. They also have remote sensing instruments that remotely view what's going on in the upper atmosphere. And then it has tasters, for lack of for a poor analogy, that taste the solar wind and what's coming in from the sun.
One of the interesting things about the instrument that's going to be tasting the atmosphere on MAVEN is that it's actually a very close relative of the one that's tasting the atmosphere on Curiosity. They have similar capability. They're mass spectrometers. They take atoms and ions, and they separate them out by their atomic weight, and they can use that to figure out what the composition is and even the isotopic ratio of some of the major elements in the atmosphere, things like carbon, and also less major elements like argon, which can tell us a lot about the evolution of the atmosphere over time.
What's it going to, before I do that, let me mention to the folks here in the Crawford Family Forum that we're getting very close to that time when we're going to open it up for your questions. So start to think of those now and how you can put those very succinctly, and then we'll give you the chance to raise your hand and somebody will come over with a microphone. But before that, Bruce, what is it going to take for MAVEN to go into orbit at Mars?
Well, first, along its way, assuming everything works in the next hour or so and it gets put on its trajectory to Mars, they will have opportunities occasionally to do trajectory correction maneuvers. So if they're not exactly where they want to be, they tweak it with the thrusters. And then when you get to Mars, you're going to do a big burn to slow yourself down and get captured into a Mars orbit, and then they'll tweak the Mars orbit from there.
So that's another tense moment. Not exactly
yes,
7
definitely.
minutes of terror, but still.
No, but it's still, Matt refers to landers going through the atmosphere in 7 minutes, but it's still a key mission phase and one that you have to hit or you probably lose the mission. And there are plenty of examples of spacecraft in history that have that have not hit that moment, and then they don't go into orbit, and then you try to figure out what you do next.
In fact, getting to Mars is really hard, and that's proven by the record of spacecraft that have attempted it, right?
It is, although thankfully our record's getting much better. But certainly with the early Mars exploration and attempts at landers being particularly difficult. But we've had, particularly in recent years, a lot more successes than failures. But fundamentally, and people lose track of it because of all the successes, space exploration's hard, and Mars, and it's another planet way out there, and you have to do a lot right. And there's no one out there to fix your spacecraft if something breaks.
And it's rocket science. Emily, do you have another update?
Oh, we're just about 3 minutes left until main engine cutoff. So maybe in another minute or two, we can bring the audio back up on the NASA TV feed.
All right.
And so they'll do a main engine cutoff, then they'll wait, what you said, about a half hour, 28 minutes, and then they'll turn back on that same engine, and after they've gone around the Earth most of the way, and then that will send them on their way to Mars, right?
Mm-hmm.
Emily, will you be continuing to cover this today?
How could I not? How could I not continue to cover it? I'm going to be on Twitter all the time, on Facebook, every single social media network I can find, and find all the best news. I've been tweeting recently a lot of great pictures taken by Jeff Faust, another of my compatriots in planetary journalism. It's going to be, and I'll do a blog wrap-up as well on planetary.org/blog after this is all over.
And that's at E. Lakdawala, which we can, I don't know if we'll have it up on screen again, but we'll mention it again before we finish up. Bruce, will you be doing color comment at Random Space Fact?
I will be doing, and having some random space facts at Twitter at Random Space Fact, or you can find me on Facebook at Dr. Bruce Betts, or on Google+. But I also wanted to comment that Emily's also got a very nice introductory blog summarizing basically the press kit to MAVEN. So if you want to get an overview of what it is and what its instruments are and what it's there to do, that's a good place to check.
Let's see if we can squeeze one question in before we go back to the NASA live feed. Anybody want to jump in here with a question for Emily or Bruce? Oh, way over here on the end. Just take a second or two here for Haley to get over to you. Hi, sir. Please introduce yourself.
Okay,
Good morning.
Should I hold it? You can hold it.
I'll hold it.
Okay. I'm Alan Markowitz, and the question that I have, I'm trying to understand what observations will MAVEN do that will help the scientists establish a in the past timeline for the loss of the majority of the atmosphere?
Great question.
Yeah, it's an excellent question because it's not a trivial extrapolation, and that's what scientists will be looking at. But what they're going to get is, basically, they're getting the input-output information now, instead of being forced to use mostly theory to understand what is the solar wind at Mars, what is the solar wind causing to come off Mars, how much just thermal escape is there just from the internal temperature of the atoms and ions, how many of them are escaping. They will be constraining all of that present information, what's coming in from the sun, what's coming out from the atmosphere, what the composition of the upper atmosphere is, what's there to leave or not leave. And then you're forced, as not surprisingly, into theory. Once you're able to nail down time now in your theory, then you can make the dicier extrapolation, but you make the theoretical extrapolation back in time. Well, if Mars's atmosphere is losing this now, and if the solar wind is doing this now, then what does that mean when you integrate that back over 3 billion years to what could have happened to the Mars atmosphere? So it's a non-trivial question, but right now we're spinning our wheels with almost only theory, and this will at least give us hard data points to use on time now to try to look back.
Emily, where are we?
We main engine cut off as expected, and it's now in the coast phase, going to be coasting for a total of 27 minutes before they reignite. It's only after spacecraft separation from the Centaur, which happens 52 minutes after launch, that they can extend the solar panels and actually establish communication with the spacecraft. So people won't be breathing easy in mission control until about an hour after launch, when we know that we have a healthy, alive spacecraft on its own.
And it looks like NASA's taking a break as well as we look. They put up a title screen. title slide. We're going to get to another question here in just a moment. But Emily, building on what Bruce said about the theory that we have, the models we already have of Mars, I don't even know if you can answer this. How good are these models? Do we know enough to know whether they're good models?
Well, one of the nice things about the solar system is that there's more than one planet. So you can build a model on one planet and see if it works when you apply it to another planet. And there are actually 4 planets whose atmospheres we are trying to explain scientifically. That includes Earth and Mars and Venus, and I include Titan when I talk about planetary atmospheres, because that atmosphere is just as big as any of these other ones.
The big moon at Saturn.
That's right. And so atmospheric scientists have models that predict the motion and behavior of atmospheres in all these different worlds. Earth's atmosphere is uniquely complicated because it's a thick atmosphere with weather, but it's also actually thin enough that it feels the surface. It feels the topography, it feels mountains, it feels the temperature difference between oceans and land. On Venus, we have a very, very thick atmosphere, so that the top of the atmosphere that we see really doesn't even know there's land down at the bottom. Mars's is so thin, it's almost the opposite, where it's a very local kind of atmosphere, even though it does flow globally. So if you can build a model that manages to accurately predict or at least explain the behavior of atmospheres on more than one of these worlds, then you know you have a fairly robust model. That being said, we don't have models that do a great job of explaining the atmospheres in all of these worlds, so we still got a lot of work to do.
And that's why we sent spacecraft like MAVEN. Any other questions out there? And if there isn't a question, I'm going to ask a guest who happens to be sitting in the front row here, if he has some comment for us. Haley, do you have the mic? Okay, Jim, do you mind saying a word or two? Jim Burke is here. Ladies and gentlemen, Jim Burke, a true pioneer in space exploration, both manned and robotic. Jim, thank you, first of all, for coming out today. You have been part of and seen so many missions. Is it still fun for you to see this stuff?
Oh yes, you're never bored when you watch a big rocket take off.
Yeah. How does this compare? I mean, you go back, what, to the days of Mercury and before?
Well, the continuing exploration of Mars, of course, is one of the great events in human history. And if this one makes it out all the way out to the planet, gets into orbit, turns on its instruments, begins finding out what happened to the top of the atmosphere, we're going to be way ahead of where we were. The Viking nitrogen isotopic data from the Vikings showed that the atmosphere had been stripped. So now what you want to do is to try to understand that process and be able to make predictions of what might be observed here and elsewhere when these atmospheric phenomena go on over geologic time periods.
Weren't you in on some of the earliest attempts to send spacecraft to Mars and the Moon, for that matter?
Where have I been?
No, where were you? Weren't you a part of some of these early missions?
Let's see. When Mariner 4 was launched, I was in the spaceflight operations facility at JPL with my then brother-in-law, the late Marshall S. Johnson, who was the creator, builder, and director of the operations facility that we then had. So that was a great moment for everybody.
First flyby of Mars, right? Didn't it disappoint a lot of people?
No, not at all. In those days, it was wonderful if something worked.
Absolutely, and that was certainly a triumph. But what it saw was not exactly the Mars we see today.
No, it was a part of the Mars we see today, a very ancient part of it that looked more like the Moon and Mercury than Mars appears now. And that ancient part of Mars is still visible and still partly understood, but there's every reason to go back to those highlands as well as to where we are going. The recent missions have had to go to low places simply to have enough atmosphere for parachutes and retro-rockets, et cetera, to work. But getting back to the ancient highlands will have the same characteristic that visiting the Moon does, of taking us farther back into the early stages of solar system evolution.
Jim, what year was that, Mariner 4?
Say again?
What year was Mariner 4? Did it reach Mars? Do you remember?
64?
I believe it was 64. Emily and Bruce confirmed that.
Yeah.
Going on 50 years, you've seen a lot of history on Mars.
Well, we just had the 50th anniversary celebration of the beginnings of planetary exploration by spacecraft when Mariner 2 went to Venus in 1962. And I'm just about to go give a paper about that. We've had a whole lot of discussions about the 50th anniversary. What does it mean? What's going to happen next? How are we going to work our way out of here to where we do have a two-planet civilization here and on the moon? We're going to need that. We need to have backup of our civilization's treasures in case we get hit here. Being hit here is beginning to attract more attention now because of what happened at Chelyabinsk recently. And therefore, we are pursuing the subject a little more vigorously than we had before. But the 50 years has given us an opportunity to think back and think forward, think of the future.
Jim, thank you for letting me put you on the spot with no warning at all, and
thank
for
you. It's a
contributing to the show
wonderful
today. Jim Burke, a true space pioneer. And Jim, be sure to let us know when you decide to retire so we can throw you a party. Still writing papers. I want to get your comments about where we are with the mission. Emily, if you have another update, of course that. And then we will wrap up with an edition of What's Up.
Well, you mean where is it now? It's flying in space.
It's in space.
Yeah.
Have they provided any other updates, Emily?
Nope, I did see, it's always nice to see a report in from Australia, Canberra, which always seems to be the Deep Space Network center that supports the most important moments on missions. They have 2 antennae ready to talk to MAVEN as soon as MAVEN starts talking to Earth. So they're green for their part of the mission.
What was that great movie, The Dish? If you want to see a terrific movie, The Dish, set in Australia during Apollo. Really excellent film. Can you stick around? We'll get some last comments from you after we finish What's Up, and then we'll wrap up for the day. So we're going to go to that special program segment now that I've been doing for 11 years with Bruce Betts, called What's Up. And it always begins with the Planetary Society Director of Projects telling us what's up in the night sky. I think it's safe to say there's something new in the night sky.
There's a spacecraft, but it's going to be kind of tough to see.
Yeah, good luck.
I wouldn't put on your easy night sky objects. MAVEN's out there. What is easy to see still, looking fabulous in the evening sky, low in the west, you can see Venus looking like a super bright star. We've got Jupiter coming up around 11 p.m.-ish in the east, and then up all the rest of the night, also looking very bright. Mars, that MAVEN's headed for, coming up around 2 in the morning-ish over in the east, and then high up in the south in the pre-dawn. We've also in the pre-dawn for a couple challenging objects. We've got Mercury, which is plenty bright but very low, but it is coming about as high as it's going to come right around now. Low in the east in the pre-dawn sky, so challenge of sunlight. And then Comet Ison is also up there. Apparently marginally naked eye visible from a really dark site, but you're still even there, and certainly anywhere else you're going to want to find or chart and binoculars or a small telescope, and that will be brightening. I'll throw out, I did put up a video a week or so ago giving the basics of Comet Ison. Is it the comet of the century or a super lame dud? Find out, or at least find out the basics about this comet and why it's gotten so much interest and what the visibility coming up is. But it is in the pre-dawn sky. It should be getting brighter if it doesn't rip apart over the next week or two, but tougher to see because it is getting closer to the sun, and we'll pass by it on November 28th. Really close.
And didn't Ison already make a pass by Mars?
A pass in a loose sense. It was closer to Mars, and it was observed from spacecraft around Mars, which is really amazing. There's a different comet that will be actually genuinely coming close to Mars next year. comet sighting spring. So we'll get you more information about that. That should be quite exciting.
Emily's anxious to jump in here.
Yeah, there's
Go.
there's another spacecraft actually that's getting ready to do observations of Comet Ison, and that's Messenger, the spacecraft at Mercury. They've already posted some test pics, and they've got several comets actually that they're looking at right now.
Very cool.
Yeah, there's a lot of comets going around. Comet Encke, Comet Lovejoy, others going around. Nothing stunningly bright to just your eye in the sky right now. We'll see if Ison survives its sun pass in November 28th, and then maybe in early December it'll be super groovy. And there's spacecraft all over the solar system that are observing Ison. It's quite the observing campaign.
Tell us about this week in space history.
Nothing happened in this week.
I don't believe it. There was a launch to Mars called
this
MAVEN
week in
spacecraft.
space history, MAVEN launched towards Mars.
All right, I'll settle for that.
Thank you.
Now, we didn't warn folks about what comes next.
Oh, there's so many possible things I could say now. But what's actually true is that we're going to ask you to help me with the weekly segment where I say the words random space fact in some odd way. I'm going to ask you to say it now. On the count of 3, I will give you a demonstration. Random space fact. 1, 2, 3.
That was sad. You have to, you gotta
They
take
weren't
another
warned.
shot.
All right, we'll try again.
Normally we would have told you about this ahead of time, but give us something that's worthy of the beginning of another human mission to Mars. There aren't people on it, but that's us.
1, 2, 3.
Much better.
Very nice.
Yeah.
Speaking of Mars, Matt, and we have been, humans have launched spacecraft to Mars 7 of the last 9 Mars launch opportunities. So every 26 months, roughly every 2 years, you get a good opportunity to send vehicles to Mars. 7 out of 9 of the last ones, including this one, humans have sent spacecraft. The 2 that we didn't hit, we actually had plans for, which was 2001. And those missions were scrapped after the 98-99 NASA Mars mission failures. And then in 2009, there were 2 spacecraft scheduled to go, both of which got postponed to 2011.
All right.
All right. We move on to the trivia contest. And we asked our listeners, what are craters on the asteroid Gaspra, first asteroid ever imaged by spacecraft? What are craters on the asteroid Gaspra named after? And this just tickled me, so we'll see if it tickles anyone else. Go ahead.
It is pretty entertaining.
How'd we do?
Very, very well. We've been getting big responses to the contest lately, and I can tell you that our winner this time, chosen by random.org, is James Miller. James Miller of, oh my gosh, Down Under, Korumburra, in Australia. He's one of those guys who's probably very proud of what's just happened in Canberra only a few minutes ago with this latest mission. And he said, James did, the asteroid Gaspar was named after its discoverer after a spa town in the Crimea in the Ukraine. So consequently, the asteroid's craters have also been named for resorts and spas worldwide. And he was very proud that he found one of the craters is called Moree, M-O-R-E-E, which apparently is a big resort town down under in Australia. I don't know, somebody here can confirm that who's more familiar with the Southern Hemisphere. So James, congratulations. We're going to send you one of those brand new Planetary Radio t-shirts.
All right. Would you like the official 4 listeners trivia contest question first?
I think we'll do that first, get rid of the listeners, so to speak. But I do want to tell you about one other entry. This one came from Bjorn Gedda. Now, you're not going to be able to see it well, but Bjorn also had the right answer about Gaspar being named and its craters named after resorts. He did point out, though, if Galileo, the Jupiter orbiter, had only been able to zoom in a little bit more closely on this asteroid, Gaspar, it might have seen the swimming pool with the little green guy and the person swimming there on that resort asteroid. So get your reservations in now. They fill up fast for the summer. Now.
Maybe next time. All right, so this question is for our listeners at home and those in the audience, but you'll need to submit your answer online.
Don't shout it out.
Well, it's okay because, Matt, this is going to be another one where we judge these answers. It's a bit more subjective than usual. So India has just launched the MOM mission, Mars Orbiter mission. Feeling left out, I have to ask, if we launched a mission with the acronym DAD, what would it stand for? We'll be looking for the answers that amuse us the most. Go to planetary.org/radio contest to get your entry in. What are they competing for, Matt?
Another Planetary Radio t-shirt, but with a bonus this time. This beautiful, pristine MAVEN mission patch that the people here in the Crawford Family Forum. Can we get a good ooh, please? Thank you so much, right on cue. And so this is a double prize for this fiendish question that Bruce has asked. Remember, you want to entertain us with this one, so give it your best shot. DAD, DAD. Okay, we're ready to go to the opportunity for folks here to win one of those Planetary Radio t-shirts.
All right, so I will ask a question. Raise your hand, and then we'll have a microphone come to you.
By the way, I didn't mention that you have until the 25th. That'd be Monday, November 25th at 2 p.m. Pacific time to get us that answer.
Got to stretch out the arm. Okay, I'll be throwing t-shirts at you. If you get the wrong size, you can try to trade it in. We have a few extras. First question, what does MAVEN stand for in the context of planetary
Raise your hand, wait for it to come over. Somebody back here, please introduce yourself, sir.
I am Liam Kennedy, member of the Planetary Society.
All right. Yay! A winner no matter what happens.
There we go. So it stands for Mars, Atmosphere, and Volatile Evolution.
Yes, indeed it does.
Bravo.
Right.
Give that man a hand. And let's see if Bruce has the arm. Oh, it just
that could be the worst throw in all the Planetary Lives we've ever done. I'm so sorry.
Now you got the hang of it. Give us another one.
By the way, I just have to comment. So technically, it seems like the N shouldn't be capitalized since it represents.
You know, it's nasty.
Maybe. All right, another straightforward answer. How many moons does Mars have?
Remember, raise your hand. Don't give it away to somebody else. There's a hand reluctantly going up here in the front and also in the back there. Your choice, Haley. Good morning, sir. Introduce yourself.
I'm Craig Connolly, better known as Kate's dad, and I think the answer is 2.
That is correct, Kate's dad.
Yay. For extra credit and no extra prize, can you name them? Just Deimos and Phobos, that's right. Thank you for lifting his arm up there, Kate. Got another one?
I do indeed. And we may have mentioned this earlier. How many spacecraft are currently working at Mars, including both orbiters and surface assets? How many spacecraft are working at Mars right now?
Not on their way.
Not on their way. Ones that are actually there, either in orbit or roving on the surface and are functional.
All right, if you listen carefully, we have a young man right over here who thinks he knows the answer. Hi, what's your name?
My name's Justin.
Hey, Justin. How many do you think are out there right now?
5.
That is correct. 5. 3 orbiters, Justin. 2 landers. Good job.
Nice work. And he pretty much got it there. Okay.
I really need to
got
practice.
One more. We'll do one more.
All right, one more. From today's launch, what does the acronym MECO stand for? For bonus points, you can give BECO, but we're going with MECO for the official answer.
How about the woman right in the back there? Hi, what's your name?
Julia Scheibmeyer, main engine cutoff.
That is correct.
Woo.
That is a long throw, too. Are you up to this?
Oh, yeah.
All right, here goes. Oh, yes!
Yes!
Good catch.
Score!
Good catch. Thank you so much. We're ready to wrap up here. Emily, I want to go back to you first just to see if there are any more updates to share.
Everything continues to look good. They're controlling the orientation of the spacecraft to make sure it doesn't get too hot on one side because there's no more atmosphere to protect it from the brilliant rays of the sun. There were about 6 minutes left until the reignition of the Centaur, and then they'll be on their way to Mars.
Excellent. Any last thoughts?
Go Atlas, go Centaur, go MAVEN.
Bruce.
This has all been very exciting. I love it when things work. And by the way, do you know the real reason it launched successfully today?
No.
I did not go to Florida to watch it.
I've heard that. It's the Bet's jinx. I've heard of this, yeah.
When I go, they delay the launch. They work eventually, but not while I'm there.
Yeah, same for me, apparently.
Yeah. So that's why we're here in Pasadena. But we've tested it out. We can do it remotely.
And we have been thrilled to join all of you here with us in Pasadena, and those of you who've been watching live, we hope around the world on the live webcast. I want to thank everybody for joining in with us at this terrific event, seeing yet another emissary from Earth make its way to the red planet. And as Emily said, go Atlas, go Centaur, go MAVEN. And go Southern California Public Radio. We want to thank KPCC once again for hosting us here today. Can we have a big hand for them? And all the great KPCC people who got up earlier than normal today and made everything work here so well. This is really not when they frequently offer events like this, so it's pretty special. And we'll hope that if we do this again, the next launch will be, maybe at 8 o'clock at night. We do have more planned. Check out planetary.org to see when we do more Planetary Radio Lives. We'll probably be doing one before long, maybe in January. And I hope that you will also check scpr.org. Look at the Crawford Family Forum schedule, because they schedule tons of wonderful events for the Crawford Family Forum. I'll be at the next one, not for the Planetary Society, but for KPCC. It's part of the next series, Science People Tomorrow, that I do for the radio station, and we will be talking about science and religion, or science and faith. And that will be on the evening of November 18th, which is December 18th. Of course, it would be difficult to do it then. It is a Wednesday, December 18th. Thank you, Janice Wachi-Hurst, who is my co-conspirator in this, producer for the Crawford Family Forum. Thanks to everybody else who helped make this happen today. And keep track, folks. Follow this mission and others at planetary.org. Take care. It's been great to join the beginnings of this trip to Mars with you. And Bruce, I saw a finger go up.
Indeed. I want to thank our fabulous audience for coming out here at an oddball time in the morning and sharing this all with us. And everyone go out there, look up the night sky, and think about ions. Thank you, and good night.
Ions. I'm on that. I didn't let him do his closing line for What's Up.
That's why I forced it in.
Talk about a jinx. Anyway, once again, thank you all for joining us, and best of luck, MAVEN, as it heads for Mars. Take care.